All right, here we go. Quadratics quiz review. We're going to be doing factored form, standard form, a little bit of graphing, taking square roots of both sides, factoring equations, pulling out the GCF, all this good stuff. So let's just jump right into it. So number one says find the solutions to, well, the nice thing about number one is that it is already in factored form. So notice the two parentheses here. So this is called factored form. And all I got to do is use zero product property, ZPP. If two things multiply together to make zero, when are u 0? X equals 4. And when are u 0? X equals -9. So I got my two zeros, my two solutions, my two roots, whatever you want to call them, and I am done. This one says find the zeros of the function. This one said find the solutions, function notation. Sometimes they'll say zeros. I just wanted you to be familiar with it. So when you find the zeros of the function, that means you make the function equal 0. Same move, ZPP. This one's a little tougher because I do have to solve it a little bit. So when does that equal 0? -5 from both sides. And divide. And one of my answers is -5/2. You could say -2.5, but I'll probably express the answers as fractions. And then when is 3x minus 1 going to equal 0? Well, 3x is going to equal 1. Divide both sides by 3. There you go. So now I have my two zeros, -5/2 and 1/3. All right, moving down. Got a couple more here, 3 and 4. The game changes slightly because now it's not in factored form, and this is going to be tough to factor because there is no x term. There's an x squared and there's constants, but no x. So usually that means I can take the square root. So I'm going to get the squared term by itself by minusing 4 to both sides. And I get 2x squared equals 50. And then I'm going to divide both sides by 2. And I get x squared equals 25. And to get rid of the squared, I take the square root of that side. I take the square root of that side, and I get two answers, positive and -5. So either number can make it work. Number 4 is very similar, except for I do have the parentheses of my squared term, but no big deal. Handle it the same way. Add 18 to both sides. So I get x plus 4 squared equals 49. Take the square root, and I get x plus 4 can either equal 7 or it can equal -7. So I got to solve those two cases. When is x plus 4 going to equal 7? Well, that happens. Why did I do 3? I'm already kind of doing the answer in my head. Don't know why I did that. -4, -4. And you get x equals 3. And then I got to solve the other case. Well, what about when x plus 4, if it equals -7? And I get x equals -11. Now, that is not the only way to solve this. If you really want to do some extra work, you could expand this out and then factor it like we're getting ready to do on the next batch of problems, and you would still get the two same answers. But I'm not going to show how to do it that way because I'm getting ready to show it right now. So good old traditional factoring is when you have something in standard form, and I see that I have an x squared, I have an x, I have a number, I have 0. I'm ready to go. I'm ready to play the traditional factor game. And that game is played by saying, I need to multiply to make 20. So there's a few ways to multiply to make 20. I think those are the only factors that can times together to make positive 20. And I also need to add to make 9. So it looks like this is the winner. So x plus 4 times x plus 5. And then I go in here and I'm like, okay, I haven't solved anything yet. All I've done is I've found the two factors. the solution is the zeros, which is going to happen at -4, and it's going to happen at -5. Boom. All right, same idea, number 6. The only problem with number 6 is I do see my n squared, I do see my n, I do see a number, but it's not set equal to 0. So let's set it equal to 0. Let's minus this 14n from both sides. So I get 2n squared minus 14n added to 24 equals 0. I don't like that 2 in front of n squared, so I think I'm going to try to pull a GCF out. I think I'm going to yank a 2 out of everybody. That's usually helpful. Now I think I'm ready to traditional factor, play my game. And so the game is, I got to times together to make positive 12. So to times together to make positive 12, we got 1 and 12, 2 and 6, 3 and 4. They're either both negatives or both positives. But I need them to add to make -7. So I think that combination will do the trick. So n minus 3, n minus 4. Those are only factors, so to get my answers, to get my solutions, it's positive 3 and positive 4. Keep on going. Number 7. One thing strikes me a little bit different is I see an x squared term, I see an x term, and I see another x term, and there's no number. There's no constant. So, that might cause for a little bit different reaction. So let's see what we got. Let's set it equal to 0. And I get 2x squared minus 8x equals 0. Well, I can't play the normal game because there's no two numbers to multiply by. There's nothing at the back. So let's just try to factor out what we can. I think I can yank a 2 out. And I think there's an x there I can yank out. So doing the reverse distributive property, that's going to give me x minus 4 in parentheses. And now I'm back to where I can use ZPP. All right, I have two things times together that make 0. Well, one of them is really easy. This is 0 when x is 0. This is 0 when x is 4. So those are my two solutions, 0 and 4. Number 8, AC or SAT simulation, very similar to the first SAT sheet we did. Let's just get after it. So when I multiply the first two terms, I get a 6. So that tells me that A times B has to equal 6. Well, that leaves some options. There's a few different options. We could have 1 and 6. We could have 6 and 1. We could have 2 and 3. And we could have 3 and 2. So there's a lot of options there with A and B. But it says right here that A plus B's got to equal 5. Well, that equals 7 and that equals 7. So now I got it down to it's either one or the other. Let's just roll with the first one. Let's try this one. So if I put 2 in for A, and I put 3 in for B, let's see what we get. Well, we get 6x squared plus 16x plus a 9x plus a 24, and that gets cleaned up to be 6x squared plus 25x plus 24. And the whole question was, what is C? Well, C is the number that's sitting in front of the x term. So C is 25. So the correct answer is B. The 30 comes from, if I would have chose this one and multiplied it out, I would have got 30. So they kind of cover both bases. Number 9, a physics problem. This one was also on the SAT worksheet we did. And we have a height equation. And we have T over there, and it says H is the height, T is the seconds, and then they got some other physics knowledge. But let's cut right to the chase. So T and H. And when we graph this, time is down here and the height is here. Well, when you launch a ball, you kick a ball or whatever, you launch it off the ground, it's going to go up as a parabola, and it's going to come down. And it's going to hit the ground. It's going to be on the ground when the height is 0. And it's going to happen at 2 different t's. One of them is going to be at time 0. All right? So when time is 0, the height's going to be 0. But the other one, I'm not sure what this t is going to be when it hits the ground. So I got to find the zeros of the function. So to find the zeros of the function, I need to put 0 in and solve it. So 0 equals negative 4.9 t squared plus 40t. And that looks, I can't really factor it. I'm missing that constant term. So let's yank a t out. And I get negative 4.9t plus 40. Well, now I can use zero product property because something times something equals 0. Well, this one we already knew. We already knew that was one of the answers. This one we got to solve for. When is this going to equal 0? Well, I could minus 40 from both sides, but then I'm going to have double negatives. I'm going to add the 4.9t to both sides, just because I like positive numbers. And when I divide it out and do 40 divided by 4.9, I got t equals 8.16 seconds. So it looks like the ball hits the ground at exactly 8.16 seconds. Now, if the SAT were to ask you, so I think the question said round to the nearest second. So the correct answer would just be 8. But if the SAT said, hey, how high is it here at its highest point? We know the highest point occurs right in the middle, which would be around 4 seconds, somewhere 4.08 to be exactly, but 4 seconds. So I could plug 4 in for t and figure out h. I could stick the 4 in up here, and that would tell me the maximum height. I think I did it, and I think it came out to be like 81.6, but just kind of giving you some extra info in case you happen to see that. Number 8, a graphing problem. This was a bad graphing problem. I didn't realize it until I already made it. But I'm going to scroll down because I'm going to show you what I'm talking about. X minus 6, x plus 4. So x minus 6, x plus 4. So when I want to graph this, x minus 6, x plus 4. If you want to graph that, you find the zeros, which is at x equals 6 and x equals negative 4. And I can put my zeros on as x-intercepts, which is great. Well, then I got to find the vertex. And the vertex occurs in the exact center of those two numbers. The center of 6 and negative 4 is right here at 1. And so I know x equals 1 is going to be my vertex. So here's what I have on my table. I got when x is negative 4, y is 0. When x is 6, y is 0. The middle point is 1. Well, to find out what 1 is, I got to plug it in, and I got to solve for it. Well, unfortunately, when you put 1 in here, you get a negative 5. And you put 1 in here, you get a positive 5. And it comes out to be negative 25. So holy crap, I'm way down here. I apologize. Ended up all the way down there. But hey, crap happens sometimes. And that's what that vertex is going to look like. Next problem is vertex form. So we did a whole section last week on vertex form. And you can look at this and get the vertex. It's the opposite of that number is your x. And it's this exact number is your y. So I got the vertex at negative 4, negative 2. Negative 4, negative 2. And now we need to get some other points. So I could plug in basically any x I want. I'm going to jump over a couple slots, and maybe I'm going to see what's happening at negative 2, just so I get away from that point a little bit. So let's put negative 2 in here. If I slap negative 2 in there, I get negative 2 plus 4, Well, that's 2 squared. Take away 2, 4 take away, that's 2. So I have negative 2 comma 2. And because of the vertex being the line of symmetry, I should be able to reflect that point over and get the other one. And now I got a pretty good, you're probably done right now. If I wanted to, I could put negative 1 in there. What's negative 1 plus 4? Well, that would be 3 squared. 9 take away 2, which is 7. So at negative 1, I go all the way up to 7, bounce him over, and that looks pretty good. Got it. Last one's going to go really fast. It's super easy. Think about our factor chart that we did where I give you clues and you fill in the other gaps. Well, x-intercepts, aka zeros, aka solutions, aka roots, they all mean the same thing. Think about a graph, and if my x-intercepts are at 5 and negative 2, and those are my zeros, that means my factors should be the opposite of those. So that one is going to be boom. Now, I tried to trick you with this one because that's what the SAT does. They try to kind of keep it the same. But remember, factors are opposite than intercepts. All right, hopefully that helps you get ready for the quiz. See you.